Differentiability and continuity. Well, first of all, differentiability just means that we're able to take a derivative. If we say that f of x is differentiable at x equals a, all we're really saying is that the derivative at that point exists. And if we say that f of x is differentiable on a certain open interval, it means that f of x exists everywhere on that interval. Just means you're able to take a derivative. Now what's interesting is the relationship between differentiability and continuity. If f of x is differentiable on a certain interval, then it is continuous on that interval. The converse to this is not true. If it is continuous, it is not necessarily differentiable. One way to think about this, if we have this big class of all functions, the functions that are continuous, well, they're one subset of that function, of that group, and then the functions that are differentiable are yet a more elite subset. So, when would a function be not differentiable? Well, first of all, it would be not differentiable if it were just not continuous. If it had any kind of jump or asymptote or hole in it, it would be not differentiable either. Second of all, it would be not differentiable if, for example, it had some kind of cusp or corner. For example, the absolute value function comes to a particular point. If it comes to a point, of course, it's continuous at that point, but it's not differentiable at that point. And then finally, it could be not differentiable if at some point during its curve, it has an infinite tangent line. For example, the function y equals the cube root of x has an infinite tangent line at the origin, so it is not differentiable at the origin. And so those are examples of ways that a function would not be differentiable.